You have heard the term electrolysis in your previous classes. Now you will learn it in details. Before going to the process, let us see an experiment. A liquid material is taken in a container. Two metal plates are immersed in that liquid, which are also connected with a 9-volt battery, a key and an electric bulb. Now, taking different liquids in that pot, we shall send current in it and observe the result. When liquid is pure water, bulb is not illuminated. When acidified water is used, bulb is now illuminated. For saline water, also illumination takes place. For sugar solution, no illumination now. Sulfuric acid, illumination occurred. Molten sodium chloride, also illumination occurred. Results of the experiments are shown in a chart. We can draw an inference from the above results that bulb is illuminated only when ions are formed from the liquid compounds. Thus, we get illumination of bulb in case of ionic compounds either in molten state or in aqueous solution or polar covalent compounds. The ions thus produced will move towards the oppositely charged metal plate and get neutralized. Ultimately, new molecules are formed there. This whole process is known as electrolysis. The liquid compounds which show illumination of bulbs are electrolyte, and where no illumination is the result, they are non-electrolyte. The metal plates are commonly known as electrode. The electrode which is connected to the positive end of the battery is known as anode, and for negative end it is cathode. And the container where this process is going on is known as voltmeter. When DC electric current is passed through an electrolyte, two oppositely charged ions are formed known as cation and anion. Cation goes to cathode and accepts electron from there. Thus, reduction is occurred at cathode. In reverse, an anion goes to anode and donates its electron there. Thus, oxidation is carried out at anode. Two new products are formed at cathode and anode respectively. Thus, electrical energy is converted to chemical energy in this electrolysis process. Platinum is the best metal used as electrode. Other metals also can be used here. Among non-metals, graphite and gas carbon are good conductor and can serve this purpose. We can extend our previous experiment by taking acetic acid as electrolyte. However, very poor illumination is the result now. It is due to its poor ionization. As we know, acetic acid is a very weak acid. So, electrolytes can be classified into two types: strong electrolyte and weak electrolyte. All strong acids, bases and salts are strong electrolyte, and weak acids and bases are weak one. We have seen electricity can be passed through a metallic conductor. But is it an electrolyte? The answer is no. Metallic conductor and electrolytes are completely different. In case of metallic conductor, flow of current is due to stream of electrons, whereas in case of electrolytes, it is due to stream of cations and anions. Secondly, the process involved in a metallic conductor is a physical phenomena, but in case of electrolytes, it is a chemical process. Number 3, with increase in temperature, resistance increases for metallic conductor and conductance decreases. However, in case of electrolytes, with increase in temperature, conductance increases. Electrolysis of molten sodium chloride. Electrolysis of solid sodium chloride is next to impossible because of its strong Coulombic force of attraction. So we have to melt it first at 803 degrees centigrade. Now the interionic attraction becomes low and ions can move when electricity is passed through it. Here the cation sodium ion moves towards cathode and takes one electron from there to neutralize. Thus, metallic sodium is the result at cathode. Again, the anion chloride ion moves towards anode and removes its charge there to produce chlorine atom. Two chlorine atoms combine together to form chlorine molecule, which is liberated from anode. Thus, metallic sodium and chlorine gas are produced on electrolysis of molten sodium chloride. The reaction involved here can be shown in this way. Electrolysis of acidified water. We have already seen that pure water is a non-electrolyte due to its covalent nature. When we add any electrolyte to it in small amount, it becomes an electrolyte. When electricity is passed through that solution, hydrogen ion, correctly H3O plus ion, and hydroxyl ions are the result. The cation hydrogen ion goes to cathode and takes one electron to produce hydrogen atom. Then two hydrogen atoms combine together to form hydrogen gas molecule there. In reverse, the anion hydroxyl ion moves towards anode, removes its charge to produce hydroxyl radical, and ultimately oxygen gas molecule is formed from there. Thus, hydrogen and oxygen gas are produced in 2:1 ratio on electrolysis of acidified water. Now, what will be the result if we make a solution of sodium chloride and water and electrolyze it? There are two cations and two anions are present in this solution now. So the question is, who will discharge first at cathode and anode respectively? We have to take help from electrochemical or activity series. If we compare their position in that series, the element or radical which is placed above is more active and more stable than the other one in the ionic form. So the bottom one will move first to discharge and products will be formed according to that. Thus, hydrogen and oxygen gases are produced on electrolysis of aqueous solution of sodium chloride. Now you practice the electrolysis of other electrolytes such as sulfuric acid, silver nitrate, copper sulfate, etc. and study the textbook thoroughly.